Hey guys, I've just conducted a little test in regards to thermal energy. Sorry. This is, as you can see, one hell of a heat sink, and this is also exactly the same, with the difference of having heat-resistant matte black paint on the back. The test I've just done is I used a gas ring from my oven, the smallest one on a low setting, and I simply held the plates. With this one, well, that's the thing, I'm confused by why using matte black paint actually helps, because it didn't. In regards to absorbing heat, standard plate worked. I tested on both sides with the flat surface held over the heat to feel how much heat actually comes through to these, and then the other way round, like so. And that way round it got a lot hotter, a lot faster. But this one right now is still warm to the touch. I've literally just done the test, put that on there, I can feel that that's warm. Put it on here, I can feel it's less of a temperature. I could also hold this one continuously. I was just holding it. It was like, okay, I'll try the other one. And with, again, this one, just a plain one. Held it, and about a minute I had to pull it down because it got too hot. So, it's left me a bit unsure now in regards to using matte black heat-resistant paint, which is what they say to use. But again, I'm thinking heat-resistant paint. Don't I want to absorb the heat? So why am I using heat-resistant? So again, it's just something's not quite clicking here. I mean, if I spray this side matte black, for one, it would be a pain in the ass to clean off if it proves useless. And yeah, it would absorb heat. I know black absorbs heat, and anything black usually gets pretty hot. But again, this is heat-resistant paint. Good for 650 Celsius, this one. So that wouldn't absorb as much heat. Or am I just, I know, am I backwards in thinking that? Because if it's heat-resistant, again, it's heat-resistant. Yeah, there's the actual words of it. Again, this one's still warm to touch, cooling down, very warm. Well, if anyone wants to know, these cost me £10.58, I think, off of eBay. Just search large heat sinks and you'll come across them. These are meant for servers. So what I'm thinking about using with these is with a Peltier device or a TEG, thermoelectric generator. I was going to stick them on the back. Well, it's best off using this one, really. I was going to stick them on the back. I know it's painted matte black, but I was going to stick them on the back with this side encased in a little glass box to trap and absorb heat from the sun. Not like a solar panel, but absorbing the heat and heating up the air within the chamber, and that heat transfers to these, which will go to the Peltier devices on the back. And that will in turn be turned into electrical energy. If I had one, well, that's why I bought two of them. I was going to put this one on the back as well. So it would have the hot side and the cool side. Sandwiched between would be the Peltier devices. But I'm left a bit unsure now because I got a lot of heat from just a normal one. A lot more heat transfer than using matte black. But then again, it could be that when it's in the sun, matte black is best, and it behaves differently when you use a flame. Another thing that I actually thought of, I might as well show it, but okay, these interlock. When they come in the shipment, that's how they were, and I looked at that and thought, if I had a Peltier device in between each one of these, I could get two of them within that space, but due to their thickness I wouldn't be able to actually get it down the gaps. However, Let's try this with one hand. Let's see if I can prop that up a little bit more. Right, that's good. If I put them like this, okay, ignore the top rung because it's just the way the bed is. Okay, if that top rung wasn't there, they drew up level. So that is enough to get a peltier device in between them. If I was to remove, let's see, on the left-hand one, I was to remove this one and this one with two peltier devices back to back, with the cold sides back to back on here and here, and with this middle one removed, I could have the two hot sides touching that, with the inner core of the peltier devices touching here, which would be hot and cold. Again, more temperature. I'm usually rubbish at explaining things. Don't worry about it. It's not you. But as you can see, well, I don't know if that side was matte black like I'm thinking, it would absorb the heat which would go through. The top two would heat on the peltier devices with the middle one removed, and then the cool one sandwiched between the two, and that would be cold. Well, that's what I thought anyway, but as it seems, that might be my hot side and that might be my cold side. I'll probably remove this. But for now, once I get the peltier device, I'm going to do a straightforward test of using something hot, something cold, to see what I get from it. I'm going to try it using my house boiler, because that's a big copper boiler and I can get a lot of heat waste from that. So I'm going to try it with a peltier on and one of these on the cool side, straight onto the boiler, see what I get, because that's going to have a major temperature difference. And in the long run, depending on, if I can actually figure out which one's actually best, matte black paint or just standard aluminium, sealed in a box to get thermal heat transfer, and again to produce power. But yeah, if anybody does really know, or can say, can clear this up a little bit more for me, I'd appreciate that, because I'm left a bit stumped. Thermal resistant paint, so why would I use it to resist heat that I want to convert to energy? I know, again, if I had this side matte black, it would increase the surface area. And maybe I don't need thermal resistant paint, maybe I need matte black paint of sorts, just not thermal resistant matte black paint. If anybody can clear that up, or has done anything like this before, I appreciate if you tell me bits of information, or guide me towards getting a more useful system, rather than basically buggering these up and being left with big lumps of aluminium. Okay then guys, yeah, take care, and I'll see you later.